Okay, 6-8 is called the counting principle. Okay.
Count Dracula.
The counting principle. Yeah, Count Chocula.
Well,
They have that Count Chocula series during Halloween time. You like Count Chocula series?
that sounds actually really weird.
Okay, so here's the deal. The counting principle. The counting principle allows us to take things and see how many combinations there are easier than drawing diagrams, like Venn diagrams for it. So let's talk about this a little bit. This problem says you are buying new eyeglasses, okay? And you must choose the frame material and shape. The frame material can be plastic or metal, and the frame shape can be rectangular, oval, cat's eye, or round. How many frames are possible? Okay?
Plastic.
Plastic, okay? Plastic is possible. We have plastic, and under plastic, what type of shapes could you have?
We have rectangular, oval, cat's eye, and I can't see that. Round.
Rectangular, oval.
What's cat's eye? Put it.
Cat's eye are like those ones that are like pointy like this.
Oh, those are disgusting.
So they're pointy like a cat's eye.
Okay, that's weird. Kind of like.
Okay, so
looks
you
like
have
Chinese to me.
Rectangular,
What are
you
we talking
have
about?
oval, you have cat's eye, what else?
And then we have round, and then it's the same thing for metal, and then we add them up, right?
Correct.
Oh, that's it.
Rectangular, oval, cat's eye,
13 different grades.
and round. So how many possible combinations do
8.
you have? You say 8? Beautiful.
Yeah.
Yeah. Yeah, 8. So you have 8 possible combinations, yes?
That's not hard.
Okay?
Hard.
Now, what happens, I didn't. What happens, yes, I did. Then yours isn't updating because it ended.
Reload.
Mine shows that it's ended.
It just ended.
That's weird. Mine shows that it was ended.
Because you didn't reload it, Bree.
Okay.
Duh.
She probably did. Hey, Gabby, eyes up here.
Sorry, I'm listening.
No, turn and look.
My
Too.
eyes are up.
I'm gonna take the hat from you if you can't focus. And then I'll give it back. Okay, so we can take lists and we can make them and count them up. The problem is, what happens if they say something like this? When you go to Starbucks, you can order coffee or tea. There are 22 different types of teas, and there are 576 different types of coffee combinations. How many combinations could you have?
0. Because
Do you see how that would be crazy to try to draw that out and add all that up?
Yeah.
Yeah, that'd be insane, right? At Starbucks, how many coffee combinations do you think there are? Like, I can
A
get
million.
peppermint in this and mocha. I could get white chocolate mocha. I could get peppermint white chocolate. I can get raspberry. I can get vanilla. I can get, you know what I'm
Wow,
saying?
That's overwhelming.
Okay, way overwhelming and way too hard to sit there and count all of that up. That's where the counting principle comes in. We take m times n for however many things. So in this case, I had 2 types of frames, and then I had 4 frame shapes, yes? 2 types of materials and 4 frame shapes. What happens when I do my 2 types times my 4 shapes? What do you get?
Oh, you get 8. So
8.
it's the same thing.
So it's the same thing, and it saves us a lot of time. Okay? You roll a blue and a red numbered die. Use the counting principle to find the number of different outcomes that are possible. How many numbers are on a dice? 6. And how many die do I have?
2.
2. So what am I
6
going to
times
do?
2.
No.
2 times 6.
Stop.
6 plus 6.
Stop.
Okay.
How many ways can I roll the first die?
6 plus
6. How many ways could I roll the second die? So what am I going to do?
6 times 6.
6 times 6.
Oh.
Because I have 6 options for the first die, I have 6 options for the second die, which gives me
36 options.
36
options.
combinations. I could roll a 1 and a 6, I could roll a 1 and a 5, a 1 and a 4, a 1 and a 3, a 1 and a 2, a 1 and a 1. I can roll a 2 and a 1, a 2 and a 3. You get what I'm saying?
Yep.
It's just
Okay.
multiplication.
It's just multiplication. Instead of adding them all up and drawing out a diagram, I can do it so much simpler.
This is
So
nice.
much simpler.
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 Okay. A combination lock has 40 numbers on its dial. To open the lock, you must turn the lock to the left, then to the right, and then to the left.
No,
Right,
and
left,
then
right. Yes, right, left, right. You randomly choose 3 numbers on the lock. What's the probability you choose the right combination? How can I figure that out?
Well, you have
Yep.
40 times 40 times 40.
Okay, why 40 times 40 times 40?
Because there's 3 different ways you do it,
Okay.
and they each have 40 like different numbers
Right,
on them.
Left,
Right.
correct?
And then
What's
that.
40 times 40 times 40?
Could you just do
40
40
times 40
cubed?
is
Could you do 40 cubed?
Yeah, what's 40 cubed?
So what's 160 times 40? So 160 times 40.
40.
A big number.
What are you doing?
The goblin.
You do 40 and then it's like
Carry.
Yep, yep.
Yeah.
64,000.
64.
64,000. 64,000. Now, it wants to know what's the probability of getting it right if you choose 3 random numbers. How would I show that probability?
Would you do something number
160 over
3?
64.
No. What's our total combinations we can have?
64?
And how many times did we try a combination?
Once.
Once, so it is 1 over,
64,000.
yes, 1 over 64,000. My probability of getting it right is 1 in 64,000.
That's a lot.
Okay, do you think someone's gonna guess your lock combination if they don't have it?
I can guess
Nope.
Ben's,
No.
but you told me.
Mine's weird.
Because they have a 1 out of 64,000 chance of getting that right. Does that make
I
sense?
don't
Carter,
remember
you
my
still remember my code for my
combination.
locker?
I just know it by like how many
Good.
yeah. Like
Okay.
I don't remember it.
So let's say
I don't
this.
know what numbers it.
Let's say you have 5 shirts, 3 pairs of pants, and 5 pairs of socks. How many outfits can you make? You have 5 shirts, 3 pairs of pants, and 5 different types of socks. How many combinations of what?
You can make 3.
No.
5 times
Wait, what'd you say?
Yes, 5 times 5 times
What was the other one?
times 3. What's 5 times 5?
25.
What's 25 times 3?
75.
Beautiful. You can have 75
I've
different
been
outfits.
doing this my whole life.
3 pairs of
What the heck?
pants.
Exactly.
I've been like writing each possible
Yeah.
thing out.
Right, so now it makes it so much simpler, yes? It's straight up multiplication. Okay? Yes, ask.
How did you do that?
How did I do this? Because the combination lock has 40 different numbers, yes?
Yep.
Okay, Carter? So in spot 1, I can choose any numbers 1 through 40, yeah? So there's 40 numbers to choose from. When I turn it again, there's 40 numbers to choose from. When I turn it again, there's 40 numbers to choose from. So I have to do 40 times 40 times 40 to get the 64,000. I get the probability because I tried one combination. I tried one random combination. Would I get it right? The probability is that I would have it right 1 out of 64,000 times.
Basically, if you try
So this is our homework?
Right, basically, if you just take 64,000 times, you're bound
That'd
to
be
get
like
it.
hours, maybe even years.
Yeah, that would, also, it would be hard to track what numbers you did, right? Like,
just write it down on page.
I'd get so confused. So yes, so you could have been doing this your whole life, Caitlin, it saved you so much time, yeah?
Why did they teach
Yeah, why did
Because they want you to understand the concepts before things, before they teach you easy ways. I know. Okay, so, yes, Bree. I didn't add anywhere. What are you talking about? Because you can add them, adding and multiplying them does the same thing. I'm just telling you the quicker way is to multiply. Showed you with adding first.
Should we go kill?
No, it would still be 8.
What?
Because you have 2 options
Should we go kill Palmer?
times 4 options.
No, you had to like.
Okay, so let me give you some homework.
Bye.